Alright, hi. We got an AIPD subcourse TR0660, edition 6 of military railway equipment. We're going to go through the slideshow. It seems to be about 111 long. Okay, from the top, subcourse TR0660, edition 6 military railway equipment. Introduction. Many old-time steamers sigh on nostalgia when a steam locomotive is mentioned, but the hissing of the steam has long since given away the efficiency of the war of diesel electric. The first American diesel electric locomotive was introduced in 1925 with 300 horsepower, one switch used rather inconspicuous the switch engine in the freight yard. On a Class 1 railroad, steam locomotion still dominated 20 years later. 39,000 steamers compared to 3,800 diesels. Within another 7 years, the diesels outnumbered the steam locomotives 30,000 to 16,000. In 1960, the steam locomotives were no longer being used at the main line. Their number has dropped to 261, while the diesel fleet has grown to be 28,278. Who knows the future of what will begin? A sigh of nostalgia. Diesel electric locomotive. Perhaps the diesel electric locomotive will, and is it one surviving competitor? The all electric that may be made obsolete by the turbine engine of the linear induction engine, or maybe some power seems to yet be created. How over the years, commercial rolling stock has been changed into bigger, better, in some instances, highly specialized basic house cars. Gondolas, flats are still in use, while will long continue. For the bigger cars have increased the fleet capacity, the total number of the cars decreased. The many different kinds of specialized cars are designed to meet the particular needs of the certain shippers and military civilians. The Army also owns and operates and maintains a diesel electric locomotive, various types of rolling stock. Suppose you received an assignment into plane rail operation for providing a logistical support for the combat of the troops and theater operations. You may need to know the equipment that you have moved to the troop supplies on the front lines who would maintain it. The text contains the 3 chapters introducing you to some of the railway equipment of the Army has provided the rail support of the tactical mission, the type of the best suited for the special jobs, the jobs and the men who mentioned it. The chapter 1 describes the Army diesel electric locomotive, how they are classified. Chapter 2, divided into 2 sections, discusses railway rolling stock, emphasizes section 1 of the fleet, especially designed built for use in Army theater operations. Section 2 discusses some of the other type of rolling stock included in the piggyback containment equipment. And final chapter outlines the briefly Army maintenance system, explaining who is responsible for maintaining military railway equipment. Chapter 1, Motive Power. 1-1. Fast, powerful, reliable, economical. The modern, highly developed diesel electric locomotive has undoubtedly found a permanent niche for itself in a prime mover. As a prime mover, it requires a minimum of maintenance, low-cost fuel, a supply of water, a small supply of water, a short warmed-up period. The diesel engine of the locomotive can produce heat units that would work more efficiently than the other engines. It is used as a source of motive power for the locomotives throughout the world. The efficient diesel engine is engines from 100 to 2400 indicated horsepower. As the source of engine to turn electrical generators has been adequately proven. The U.S. Army owns diesel electric locomotives for the training of transportation railway service personnel in their operation, for the use of utility road services, and for the combat logical support. The chapter describes the Army locomotive, explains the system, and used to classify them. 1-2 Diesel electric locomotive. Diesel electric locomotives in the efficient self-contained unit with all parts properly coordinated with the providing motive power with railway equipment. The major parts of the diesel engine head to furnish primary power and generator electronical equipment to transit power for the generator to the wheels of the trucks, deep in the driven wheels on the rails, keep driving on the wheels and under the frame of the cab to hold the truck in the line and support the engine and generator and control equipment and compressor, other necessary equipment. The diesel engine is the locomotive internal combustion engine similar to that used by the automobile. The diesel engine is usually a compression ignition process of which the air is compressed extremely high pressure, resulting in high temperature with the cylinder. The fuel oil injected within the cylinder is ignited with the high temperature compressed air, and on the other hand, the automotive engine is used as a mixture of gasoline and air, is ignited by the spark plug from the spark plug. The mechanical energy output of the diesel engine is converted by a generator into the electrical engine and electrical energy, which powers the traction motors that drive the axles and turn the locomotive wheels. The 3 represents the diesel electrical locomotive the Army owes the operators described briefly on subparagraphs through the classification of 0660, etc. explained on the paragraph 1.3. The 0660 Wyatt Model 120 road switch locomotive shows that Figure 1.1 is designed for the use of heavy duty in the yard services. It may be used as a single multiple unit standard and broad gauge railways. The 120-ton, 1,600 horsepower locomotive is highly versatile and suitable for operation under extreme climates and adaptable foreign domestic coupling and arrangements. The locomotive is often referred to as an MRS-1, and the MRS stands for Military Road Switcher. Here's a train. It's in black and white. The pictures are no better than this in the book. The 0440 Lewis model, the 100-ton switch SW8 locomotive shown in Figure 1-2 designed the heavy-duty road switching services standard gauge railroads, both in continental United States, foreign countries. It has up to 800 horsepower engines, the multiple unit capability. The Lewis engine 0440 60-ton locomotive shown in Figure 1-3 can be used in both road switching services. It may be used in single multiple units on broad gauge railroads. The locomotive has about 500 horsepower diesel engine and can be used on both. 1.3 classification. Locomotives are classified in various ways by size, horse, and by tractive effort. However, none of these are completely descriptive, adequate for all purposes. The mostly widely used accepted system of classification is the Wyatt classification system. It was developed in 1900 by F.M. Wyatt at Mechanical Engineering of New York's Central Hudson Railroad system, is generally accepted by the Great Britain and the British Commonwealth in North and South America. The Wyatt classification is based on the normal number of locomotive wheels on the axle. Each type of the truck's wheels. The trucks are the 3 types: leading, front, driving, and trailing rear. The truck is termed the used and designated wheel assembly support. Locomotives are car body. The Wyatt system uses a series of digits, the numeral separated hyphens, to specify the number of wheels each type of locomotive for truck. The first numeral denotes the number of the wheels in the leading truck. The next one or 2 represents the number of the driving group. The last specifies the number of the trailing truck. The number always refers to the wheels front from the rear. Digits are omitted if there are not leading or trailing wheels in use. All wheels are Army diesel electric locomotive drivers. There are no leading trailing wheels. The diesel have either 2 or set wheel trucks, 2 sets for 4-wheel trucks. Therefore, the digit 0660 denotes that no leading truck wheels. They have 2 sets of 3 driving wheels, which are 2 wheels on each and total 12 wheels. Driving wheels. Likewise, 0440 locomotive would have leading, trailing wheels, 2 sets of driving axles, as a total 8 driving wheels. Figure 1.4 illustrates the Wyatt system classification diesel electric locomotive. Another system commonly used in Europe, other parts of the world, in the figures identify the diesel electric locomotive. Its axles, letter used in driving axles, numbers of driving non-driving axle. In this system, the A stands for the driving axle, the B stands for 2, the C stands for 3, and the D stands for 4. A small O is placed in the initial letters for each axle that is individually powered. The single unit of the locomotive is 2 individual powered. 2 axles would be classified as a BO. One of the 3 axles in the center of the axle is idler would be designated as a A1A, 1A, A1, A1A, A1, A. Summary: the diesel electric locomotives have internal combustion engines that furnish the primary power of the electrical equipment to transmit the power to the engine and the driving wheels. The engineer figure the 1.4 the Wyatt classification diesel electric locomotive cylinder high compressed air reaches a high temperature and provides a spark for the engine of the fuel engine of the injected the cylinder. Army locomotives classified in the Wyatt classification according to wheel arrangement from the front to the rear. The series of the digits is separated with a hyphen, specifically the total number of the wheels of axles, each type of the truck being in the leading of the truck, not driven wheel. Then the trailing truck, the Army diesel electric locomotive having neither leading nor trailing truck at the wheel of the drivers. The locomotive generally has 2 sets of either 4 wheels or 6-wheel trucks. Here's the example of the 0664 diesel electric locomotive, no leading wheels, 2 sets of 6 power driving trailing wheels. 0440 diesel electric locomotive, no leading wheels, 2 sets of 4 power drivers, and no trailing wheels. Chapter 2, rolling stock. The first railway car, mostly horse-drawn wagons, they were introduced in England in 1602, transported loads of coal from English mines to navigable streams where coal was transferred into vessels. The wagon was equipped with the hand brakes to reduce the speed. When they started rolling faster than the gait of the horses, they pulled them out. They pulled them. They had wooden wheels and rode on wooden wagons, way of rails called tramways. Experience soon provided that the wooden wheels and the rails wore out quick, had to be replaced. Then this led to a metal wheels or rails. But at this time, the industry grew, and the limited capabilities of horse and wagons could not meet the demands of transporting even ever increasing tonnages. Some of the method of the transportation was needed. The cold bolt could be both heavier and loads withstanding.